Hi students, last session we have discussed about time and space complexity, where the time and space, how we can easily retrieve and easily can able to compress, and we can easily able to execute the programs we can easily see in there. So now we are going to see about asymptotic notations. It's next part of the thing, and will be some of the contents what we have seen the time and space complexity will come in the asymptotic notations. Asymptotic notations describe the growth of the algorithm complexity. So how the program is more complex in terms of input size. How much input size we are going to give. When we given a large input size, what is the complexity will occur? And also has to evaluate the performance for larger inputs. The same thing what I have given, what I told. When more number of data, integers, values, when more number of values are given, the size is more big in n values, they abstract away machine specific constant and lower order terms. So we are going to see about how the program algorithm is more complex, and what in terms of giving how much size we are going to give as an input. So the in notations, these three things are very important. Big O is an upper bound, omega is a lower bound, and theta is the tight bound. So big O will be used for all the programs. Omega we will not use here, so it will be a lower bound value, success rate also high, but we are not using regularly. Theta value will be a median value. If 0 to 100 we have taken, the median value divided by 2 we will be used for theta values. So it's used to classify the algorithms based on the growth rates. So big O notation is what case? The first heading describes the upper bound of an algorithm. We have seen and the running time guarantees that the algorithm won't take more time than its bound. Okay, use to evaluate the maximum time of an algorithm that may take for finding the time complexity, and also it will use for algorithm how difficult the algorithm is. This is the simplest example. The same example what I have taught in the time and space complexity. I is equal to 0, I is less than an I plus plus. So here the time complexity will be big O of n. So here the time complexity is based on how many times the for loop is going to run and what's where time and space will be taken. Second one is omega, describes the lower bound, guarantees that the algorithm will be at least takes this much time. So it will be guaranteed, it will tell that this algorithm will take this much time to complete the program. So if the for loop has I have given some value, this omega will give a clear picture about the timing, how much times the for loop will be retained and what time it will give the what time we will get a clear output. Used to express the best case performance. Omega notations will be, I have given a linear search tree. We all know that the linear search tree will be in the beginning time the omega will be given, the complexity will be omega of 1. The time complexity will be big O of n. Here it will be omega of 1. Okay, so we have clearly understand regarding these two things. The omega notations is the best case. We have seen the thing. And third one is theta notations. It's a tight bound. How we will find the tight bound? Based on the median of the value what you have taken, and the finding the answers for the median is called theta notations. Describe the extract bound of the algorithm, and also it means the time taken in the both upper bound and the lower bound. That is both big O and also the omega. In between the value it will be calculated here, and the ideal when best and worst case are there in the same value. So the ideal when best and worst case, big O and omega values. So this is the notations. For I equal to 0, I is less than n, I plus plus, sum is valid, the time complexity is theta n. The same example I have given, go through the why means you can easily able to understand the programs and the notations what we are given. So this is the program I have taken for this same program. Here I have given a value 3. So 3 means the 3 value has been calculated here based on the thing. So I equal to 0 less than an I plus plus. So the notations values and also the time complexity we have used. Here big O notation has been used for calculating the programs. The big O will be a nested loops. N square will be followed. So the time complexity O n square due to the nested loops. Y means here it will be a 2 times the value, so the O n square will be present. So it is the nested loop of the value which what we have been taken to the find answers, and also it also analyze the programs. So here 3 types we have seen here. Once again I will repeat you. Big O is an upper bound, omega is the lower bound, and theta is the tight bound. In the upper bound, the programs will be, if the algorithm running time guarantees that the algorithm won't take more time. The algorithm will not take more time. But when we come to omega, guarantees that the algorithm at least take this much time. And when we come to theta, so it means that the time taken in both upper bound and lower bound by the same function. Okay. So this is the explanation, and this is the compiler output of the program. Now I have given n equal to 3. So the 3 values has been combined. The notations will be calculated and time constant will be found. So 0 to the 3, 0, 1, 2, 3 values has been taken, and they are finding the output whether which one will be the same, and they will find whether the program is having error or not, and it is identify whether it is a good program or not. Okay, that's all. So thank you very much for joining with me.